All right, lesson 55. Advanced abstract equations. So we're going to jump right into one of the problems because the steps are the same as the other lesson where we learned abstract equations, but we'll still go through them. All right, so we're solving an abstract equation. That means an equation that has all letters in it. And we need to solve this equation for m.
So we need to
Solve for m.
common denominator.
So first find common denominator. What is the common denominator?
XM.
xm. And then what do we do with the xm?
Multiply xm to every variable.
Every term. Every term. So everything gets multiplied times xm. So what's different, or why these are advanced, is because some of the terms have, or some of the fractions have multiple terms in either the numerator or the denominator. So we have to be careful about that when we multiply, that we make sure we multiply by both of them. So I multiply everything by the common denominator. I then cancel the things that will cancel. And then I do my multiplication. M times A, M times B, so I have MA plus MB. X times Y, so plus XY equals KXM. So that step of multiplying by the common denominator eliminates all the denominators. So since we're solving for m, now here's what we need. We need every term that has m in it on one side of the equation. And this is where, excuse me, this is where you can make a different choice, where somebody might say, I want to move all the m's to the left side. Somebody else might say, I want to move all the m's to the right side. And they will get answers that look different. But are they? They are not. Okay, so on this first one here, I'm going to do it both ways just to show you what happens, and then after that, we'll just do it one way. All right, so the person that said, I'm going to leave all the m's, put all the m's on the left side, is going to have this and this. So actually, that got a little bigger than I wanted to. Minus x, keep forgetting, minus xy. Somebody else says, you know, I want to put all the m's on the right side, so I'm going to leave xy on the left side. KXM minus MA minus MB. All right. So the next step is, once you have the variable you're solving for on one side, you factor that variable out of all those terms. M times A plus B minus KX. This one over here would look like M times KX minus A minus B. All right, and then anybody remember the last step?
Yeah, if you gotta divide that thing.
Divide by, it's the coefficient of the variable you're solving for. All right, so same thing here. Minus A minus B, KX minus A minus B. All right, so these are the two answers we get from two different methods. Are they the same?
Yeah.
How do you know?
Because all the signs are the opposite.
Yeah.
Well,
It has all the same terms. Every single sign is different. Negative XY, positive XY. Negative KX, positive KX. Positive B, negative B. Positive A, negative A. Every sign is different. That means it is the same answer. Okay? So that, when you make that decision about which side to move it to, it doesn't matter. You can always check to see if your answer matches up by just checking the signs. All right. Pretty straightforward problems. We'll do the third example. The second example is almost identical to that one. The third example has a denominator that's a little different, so we'll do this one. Because this denominator has an A and a B, or an A plus B in it. They're not multiplied. So when we find our common denominator, we just treat that whole thing as one factor. So our common denominator is what?
Y times A plus B.
Y times A plus B. So this is where I have to multiply. Okay, so the y is missing a factor of a plus b, so I need to multiply that in the numerator and denominator. The a plus b is missing a factor of y, so I need to multiply by y. And then what do I multiply this p by? The whole denominator, right? Because it really has a denominator of 1. So it might be easier if we think of it like, no, let's not do that. Nope. All right, so every term needs multiplied by what? Wait a second. I totally messed this up. Back up. What did I mess up? Anybody know?
No.
Yeah. So I accidentally switched to a different problem, and I was finding a common denominator. That's not what I'm doing. We need to multiply every term by the common denominator, okay? Sorry, my mistake. So everything gets multiplied times y times a plus b. Because then if we did it the way I was just doing it, we wouldn't be able to cancel. So y, a plus b, a plus b. So when we multiply this, make sure we multiply the mx times both of these.
So the MXA plus MXB.
mxa plus mxb plus yd equals pya plus pyb. Multiplying that out the same way, distributive property. All right, so I never wrote it down. What are we solving for? All right, we're solving for a.
MXA to both sides.
And then subtract PYB to both sides.
So you say take that over here, take this over here.
Yes.
All right, so then we have mxb plus yd minus pyb equals pya minus mxa. All right, good problem. All right, we're solving for a, so our a's are all on the right side, so we need to factor a out of the two terms on the right side. All right, nothing changes on the left side.
And you divide the coefficient.
Then we divide by the coefficient of a so that it cancels out on the right side. And then our left side is our answer. All right, so solving abstract equations, the steps are exactly the same as the other ones we did. The only reason they're calling these one advanced is because they have some things, some numerators or denominators that have two terms added together. All right, there's another thing in this lesson, word problems and quadratic equations. Anybody know what a quadratic equation is? Yep. It does not. The word quad usually means 4, but I don't know what's 4 in these equations. Quadratic equation is an equation that has a variable to the second power. This is a quadratic equation. So,
Haven't we already done that?
we've already done quadratic equations, we just haven't had them happen in this type of problem. So when you do have a quadratic equation, we'll get to this problem in a minute. When you do have a quadratic equation, what are your methods of solving it that we've learned?
Add 5 to both sides.
Possibly. Then what are you going to do?
Then you would find the
You would factor x squared plus
No.
3 squared. to both
So,
sides.
if we move 5 over to the right side, we're going to complete the square.
Yeah.
The other option is factor it, but does this factor?
No.
Doesn't factor, so we would need to use quadratic or completing a square. So if it factors, that's a much easier way of solving these types of problems. If it doesn't factor, then you have to use completing the square. So this type of equation can sometimes happen in a word problem. So we're going to look at a word problem, example 55.4. Find 3 consecutive integers. Anytime I read 3 consecutive integers or 4 consecutive, all right, I write this down All right, what's my first integer? N or X or A or B, whatever letter you want, right? For some reason I like X better. All right, so if my first integer is X, what's my next one?
X plus 1.
How come sometimes we do X plus 2?
Because that would be for even or odd.
Yeah, so this just says 3 consecutive. It doesn't say even or odd. So X plus 1, X plus 2, that's our third. So these are our 3 integers that are consecutive. All right, such that the product of the first and third. What does the word product mean?
Multiply.
So I need to take the first one times the third one. The product of the first and third is 4 greater
Plus 4.
minus 4, unless you do plus 4 on the other side, is 4 greater than 4 times the second. So it's very similar to the other ones we've done, except for the fact that we're multiplying 2 the integers together. And when we do that, we end up getting a squared term. So x times x is x squared, x times 2, 2x, minus 4 equals 4x plus 4, because this also is distributive property. So anytime you're solving a quadratic equation, it's probably best, because this will work for completing a square and another method we're going to learn later. Move everything to one side. Everything to one side, all right? 2x, all right, if I bring that over here, in other words, if I subtract 4x from both sides, I get negative 2x. Oops, what's a positive 4? All right, so if I subtract, why did I write it? Subtract 4 from both sides, then I have this. So now this is the form that we want it to be in. And from here we could say, okay, let's either factor it or let's complete the square. Or there's a third method we're going to learn, use the quadratic formula. We haven't learned that yet. So if it factors, that's a much easier way. Does it factor?
X or no.
Minus
Yeah,
4 times x plus 2.
It does factor.
X.
Because if it factors it, you get to the solution much quicker than when you do the completing the square. But what if you looked at it and you didn't realize it factored and you went and did completing the square?
You could add 8 both sides.
Would it work?
Yeah.
It would. So if I factored it, what do I do now?
X plus 2 equals 0 and x plus, or x minus 4.
All right, so x equals
Negative 2.
-2.
X equals 4.
Is that my answer?
No.
No.
No, it said find 3 consecutive integers. Guess what? There are 2 answers. -2, -1, and 0 is one set of 3 consecutive integers that satisfy this. But so is 4, 5, and 6 are also a set of integers that satisfy this.
How did you find 4, 5, and 6?
By, these are my integers. So when I got x equals 4, my next integer is 5, next one's 6. So these are my starting point. That's my first integer, that's my first integer.
Oh, okay.
Because I'm looking for consecutive integers. Joe?
So will they ask for both answers?
Yes, both answers,
Oh, okay.
definitely.